Welcome all of you. Today we are going to deal with material balance calculations. So to understand the material balance calculation, we must have to introduce to ourselves some of the basic concepts that are very essential in order to do material balance calculations. So the first one that we must have to understand to ourselves is the fundamental law of material balance. Fundamental law. That law is law of conservation of mass. This law, what it states that mass neither can be created nor it can be destroyed. It means that whatever the mass that exists in the universe remains constant. Therefore, we can say that whenever we are doing any material balance calculations, we should know that whatever the input that is coming into the system or the input that is introduced uh, must be equal to the output that is coming out of the system or that is coming out of the process. That is, input should have to be equal to output. That is, mass should be balanced. Okay, mass should be balanced. So we can say that any of the process that we design, okay, any of the process that we design, it may be a newly process, it may be a new process, okay, or any of the established process that it shows or it must have the input and output of the entire process equal, or each of the individual unit, okay, that is coming into the system and going out of the system should be balanced. So this is what the objective that we keep in our mind before understanding the material balance calculation, because the law must hold the law of conservation of mass. It must hold. So another terminology that we must understand, this one is the system, surrounding and boundary. So what is system? System is a arbitrary portion, okay, it's a arbitrary portion of a process which is under consideration for analysis. Okay, this is a system is a arbitrary portion of a process which is under consideration for analysis. Suppose you can take one of the a reactor, any of the unit operations like distillation, then you can take column chromatography, whatever it may be. Okay, so where the process may be going on, we could call this as a system. Okay, we could call this as a system where some process may be going on. It may be physical process, it may be chemical process. Okay, so this system, okay, this overall system is a part of, okay, it is a part of one of the large portion, okay, what we call this as a surrounding. Okay, this system is a part of the surrounding. Okay, system is a part of the surrounding. uh, Therefore, this system, to differentiate from the surrounding, what we require certain boundary, because here in the system certain process is going on, certain process is going on. So this system can be differentiated from the surrounding by what we call this as a system boundary. Okay, what we call this as a system boundary. So this boundary or this system boundary is an imaginary boundary. Okay, is an imaginary boundary which separates actually system from the surrounding. Okay, this imaginary boundary, there is a system boundary. Okay, it is separate system from the surrounding, and therefore this boundary actually help us to understand that the system is a different part from the surrounding, where the system would be undergoing some sort of process, or the system is a part where the some sort of process is going on. It may be a chemical process, suppose, or it may be a physical process, while the surrounding is a what we say a outside portion of the system boundary. It's a outside portion of a system boundary. It's a outside portion of the system boundary, and this system and surrounding are mutually interacted. Okay, mutually interacted, it means that the mass or the substance or the matter that can enter into the system from the surrounding, or energy can enter into the system from the surrounding. Moreover, we can say that the system can exchange the mass as well as energy. Okay, mass as well as energy with the Surrounding. So system and surrounding are mutually get interacted through the system boundary. Okay, through the system boundary. So we can say that system, surrounding, and boundary help us to understand, to do certain types of material balance calculations. Now this system, okay, this system is actually is of three different types. The first one is the closed system. Okay, as you all know that what is exactly a closed system. Closed system is nothing but a system in which no mass exchanges, while no mass exchanges with the surrounding, while you can exchange the energy, or the energy can be exchanged from the surrounding into the system, or from the system it may be passing on into the passed on into the surrounding. We can say that this system as well as the surrounding may be mutually interacted uh, by exchanging the energy, that the energy can come into the system or energy can go out of the system, while there is a restriction for a mass to enter into the system. We call such systems as closed systems. Okay, we call such systems as closed system. Okay, so we can say that there are a few examples in our day-to-day life that we take. Pressure cooker, mixer, or blender is one of the best examples that help us to understand how a closed system behave. Okay, so you know that in a pressure cooker, once the food material is introduced and the lid is closed, then it is being placed on heat or some gas where it may exchange. Okay, it may exchange the heat, and this heat may be used in order to cook the food. Okay, but during the process, no matter or no substance can be further introduced into the into a pressure cooker. Okay, so here we can say that mass is not allowed to enter into the process or into a system once or initially when it has been introduced. Okay, but energy can be exchanged directly. The energy can come into the system as well as the energy can go out of the system. Okay, so pressure cooker is the best example of a closed system. Moreover, there is another example that we use in our day-to-day life is the mixer or blender. Okay, mixer or blender. This mixer or blender, okay, how take some material which is to be crushed, okay, which has been closed from both the side, okay, and this is directly connected to some electrical devices where from the electricity enters, and this electricity get converted into some sort of mechanical energy, and this mechanical energy is used to crush the material which is present in the mixer or blender. Okay, mixer or blender, whatever the material that is there in the mixer or blender, it uses the mechanical energy to get it crushed into fine pieces. So here we can say that the material once enter into the system, we never allow, it's not possible to introduce further more material or mass or substance into the mixer or blender. But electrical energy, it's a source of energy. It comes into the system where it can be where it get converted into some mechanical energy. It means that energy can enter into it. Okay, energy can enter into it, while or energy can go out of it. So energy or heat, whatever it may be, so this can be exchanged, but there is a restriction for the mass to get it introduced into the system. Okay, so these two, pressure cooker, mixer or blender, this is the best example that we often use in our day-to-day life. Is a example of what we call the closed system. Okay, and next is the open system. As name itself indicate that there is no restriction for energy as well as for matter to get it exchanged with the surrounding. Okay, this energy, matter, both can be exchanged from the system to the both can be exchanged That means it can move from system into the surrounding, and from surrounding it can cross the system boundary and enter into the system. So such is the way in which energy as well as matter can both get exchanged. Okay, both get exchanged. We call such systems as open system. Okay, open system. So here you can see a pan in this is a pan wherein there is a boiling water. Okay, so boiling water is there, so you can introduce the water into it, as well as you can introduce the water into it, as well as you can take out the water. Moreover, energy can enter into it. Moreover, the energy can as well as the energy can go out of the system. So such a system in which both energy and matter can be exchanged, we call this as a open system. And the third one is the isolated system. Okay, so isolated system is not very much required in order to perform the material balance calculations, but still we must have to understand to ourselves what exactly is a isolated system, because we are dealing right now here is the basic concept of system, what exactly is a system and what are the different classes of the system. So the first one we have dealt with the closed system, the second one open system, and the third one is the isolated system. So in the isolated system, or a system which can be called as a isolated, in which there is no exchange of matter as well as what we say energy. Okay, such is a system what we call this as a isolated system. There is no possibility of entrance of any kind of mass into the system, as well as there is no possibility, or there is no chance for the energy to come into the system as well as to go out of the system. So such a system what we call this as a isolated system, and the best example is the thermos flask. Okay, thermos flask that we use in our day-to-day life. This thermos flask we use for keeping things at its condition. Like suppose if we introduce cold water into a thermos flask, it remains cold unless and until you open the lid. Okay, similarly if you keep a cold coffee, hot tea into the thermos flask, it remains at the same condition, or it remains at the same temperature in the thermos flask. Whatever the period you keep it into the thermos flask. So you can say that thermos flask never allow any mass later on to be introduced into it, as well as no energy can be exchanged with the surrounding, or the energy from the system cannot cross the system boundary and get into the surrounding. So and similarly from the surrounding the energy that cannot come into the system. So this thermos flask, or in an isolated system, there is no way out for exchange of matter as well as energy. So thermos flask is the best example of isolated system.